Hi, I'm Steef-Jan, Technical Integration Architect at HSO, a Dynamics partner from Microsoft in the Netherlands. My Twitter handle is @Steef-Jan, so I'm going to talk about building event-driven solutions with Azure Event Grid. So this is my to-do list. So I'm going to talk about a little bit in context of the technology Azure Event Grid with regards to event-driven architectures. Then I'm going to talk about event-driven solutions in Azure, leveraging the Azure Event Grid service. Some use cases, demos, the Azure competitors in this space, particularly AWS, Triggermesh, and Google, and some takeaways. Okay, so event-driven architecture. What does this actually mean? Well, it kind of means that systems through APIs will send out events notifying each other that something has changed and allowing maybe those APIs to get data from one system to the other. With this way, with this kind of style or this implementation as such, leveraging something which is called an event bus that can route those events from API A to B to communicate with those systems, it's kind of near real-time communication. Hey, something has happened. Okay, I'm interested. What happened? I'm going to get that data. Something that's changed in your system. And through this, eventing and leveraging something like an event bus, in this case, allows you to do some loosely coupling. And through that mechanism, systems are basically unaware of each other. Other than once the notification event comes in, they can respond to it if they want to. And this kind of facilitates something like a plug and play type of architecture. So I can remove one system and replace it by another system, which subsequently can respond to events from other systems saying, hey, I got data. So the data exchange and consistency can remain in place. And the data exchange, as depicted here, is solely based on events, where there's an event bus routing those events from A to B. And what are these events then? Well, it could be a temperature change, because an event is always something that's happened in the past. It's a fact. It could be a state of an object that changed, or with an average subscription, that something has changed in the subscription itself. Is this event thing new? Is EDA, the event-driven architecture, new? No, not at all. This paradigm and event-driven architecture has been in place for quite, some time. Even back in the day, like when I was working with BizTalk Server, you could have events sending out messages, which are through this message broker box product routed to other systems that were interested kind of in these events, and as in you kind of configured the configurations to allow them to accept or receive those messages, but then also in a kind of a loosely coupled way. Systems are decoupled with this broker product in the middle, and then you can also use something like a canonical data model to also decouple data formats and the contents of data. So then you have a complete loosely coupled landscape with this broker product in the middle, leveraging like a PubSub architecture with its message box. So messages come in and they're distributed to those systems that subscribe to them. At least that's the way you configure it. So this complete, this event-driven architecture is not new. But instead of messages, we're talking about events. So events are being distributed, leading to the fact that this data is going to be exchanged. And that's a bit different compared to the box product. Okay, so event-driven architecture in this architectural style, when would you use it? Well, if multiple systems have to process similar events and react on those, you can do real-time processing with a minimum time lag, as like near real-time processing between those systems. So once system notifies the other through an event, at least it goes to the event bus, that system like, hey, I'm interested in an event, I'm going to fetch that data. Also to keep some of the systems of records, I would say, in a certain way in sync. Consistent. You can also leverage this event-driven architecture style to do some complex event processing, pattern matching, aggregation over time windows. You can even have high volume and velocity of data. So you can talk about IoT style of solutions where also, you're talking about a massive amount of events. So you can either plug into those events and take those events out which you're interested in. So if there's a large stream of temperature data and the temperature starts to rise, you see this trend because you're kind of monitoring, or at least you're ingesting all that events, you can subsequently react on that. We're going to dive a little bit more into how systems would communicate with each other for this event-driven style, saying, hey, there's a change in my system, and then you're going to fetch that data in line with those types of solutions. Okay, and building those solutions, you can use something like Azure Event Grid, which was the latest addition to the Azure integration services. So it already had logic apps, API management, and service bus in its midst, and then also eventing. So Event Grid for event-driven type of solutions. So with a service bus, you get messages on, in a queue or a topic, and then, your subscribers are pulling from it. But with Event Grid, it's more like the sources or systems pushing those events, and then immediately are being pushed to the subscribers, which subsequently can react on that. So that's a bit of a distinction, and that's what this service is offering. So you got your event sources on one end, which could be multiple Azure services supporting Azure Event Grid. Could all be a custom application sending events to the Event Grid topic, so you create a custom topic. Or even when it's supported in Azure services, it's called a system topic. I'll talk about that later. But those events are being sent to an Event Grid topic, which subsequently route those events to anyone who's interested in. So those are the event handlers. Could be service code, like a logic app. Could be a function. You can also send those events to event hubs or storage queues if you want to later on, process those or buffer those events for later processing. And there's other, application services that can subscribe, on an Event Grid and getting those data or getting the events. Okay, so what are the concepts? So the concept is straightforward. Event happens, and it happens inside a source. Could be a blob storage, a new file is being dropped inside a container. So, blob created event. So it will publish, because that's where the event took place. It will publish those events to a topic. So that's where the publishers, like, where event happens, send, their events. And then on the other end, you have one or multiple subscribers saying, hey, if that happens, I'm interested in this event, and they're subsequently going to handle it. So you get events, event publishers, topics, event subscribers, and event handlers. That's the general concept of the service. And those events adhere to either a proprietary Microsoft schema, which is depicted on the left-hand side with a couple of mandatory properties, and the data property containing the unique elements of the event taking place. So, for instance, blob created, and some of those characteristics and properties are inside a data element. And then you also have the cloud events, which is an initiative by the CNCF, Cloud Native Compute Foundation. They've created a similar schema, but with different property names. But again, there's a data element containing those unique event properties. Both are JSON schemas. And Azure Event Grid supports both. It has, of course, its proprietary schema, but it also has the cloud event schema. And then the routing of events. How is this happening? Well, Event Grid, the key capability is intelligent routing, as in, you push those events are being pushed, and then based on subscription, based on filtering, those events are being pushed to those who are interested in through this subscribing mechanism. That's the intelligence. And the routing is done through subject, type, and data. And what are the examples then? Okay, you can do event type filtering. So it's just the type of the event, which is a property in the name in the proprietary schema. But also in the other schema, it has this distinction like, this is what happened, this is the event type. And here are just examples of a service in Microsoft supporting Event Grid and sending something out like reset write failure or reset write success. Those are the kind of events that service supports. Could also be subject. So when a blob's being created inside a storage account, then you specifically might want to, if it's in a certain container being created, you're going to subscribe to that container, and then maybe you're only interested in JPEG files. And then the other thing is you can do advanced filtering. And that's based on the elements or properties in the data property of that event. And then you can say, hey, if a certain key is there and it has a certain value, then I want to have that event. So you can have some fine-grained filtering of events. But what about some event-driven solutions? So I got Event Grid, but how does it fit in a certain solution? Let's look at a cloud-native integration between two SaaS systems. So in one SaaS system, an entity changes, which has to lead to the fact that that data in that entity has to be pushed towards another service, which is ServiceNow in this picture. So Salesforce is sending out in general just events like this happened. It doesn't adhere to a proprietary schema in this case. When we're implementing this, we're like more, okay, just send the event with, what type of event, which object, what type of identifier. We'll just map it in a logic app, which is an HTTP logic app secured by API management. We'll do the mapping, push the event to an event grid topic. We have another logic app behind it, which subscribes to certain events. There's multiple handlers. Let's say certain object chains. We have a specific handler for it. It will call out to Salesforce through API management again, get the response back, send that response, or at least map it to the proprietary or to the format it requires in ServiceNow. You also see some policies here. One depicts the fact that each call to Salesforce has to have a token. So there's a generic policies for that one, and when the response is being mapped to a canonical data format and so forth. So this is kind of cloud native integration where you find Event Grid as a part of this solution. Then there's another cloud native integration, but then supporting Dynamics 365 Finance and Supply Chain Management. Because Dynamics Finance and Supply Chain Management now has this capability of sending out business events. So you set up a business event inside Dynamics on a certain entity or entities, and then you configure it, and then you send out a business event to an Event Grid topic, adhering to the Event Grid schema. So that's what you configure in Dynamics, push out the event to a topic. You can also push it to a namespace in other ways, but you can also push it to a topic. Triggering, because there's a logic app behind it, which subsequently will get some of the data out of Dynamics 365. Enrich the data because it does multiple calls. You see this app registration because there's a trust between Dynamics and logic apps, some security involved. Get some of the data, push that data to a service bus namespace, to a queue, because it's an enriched message in this case, and then there's another logic app receiving the message and sending out a text file. Just in general, this is a little bit of a complex picture, but just, this is a sketch of one of the solutions we're currently implementing where a business event is being sent to an Event Grid topic. And last but not least, I have another sample of an event-driven solution. This was presented by a premier field engineer from Microsoft 2 or 3 years back during a Global Integration Bootcamp session in London, where this service was really released and was made available, and Microsoft already created some case with their toll road from Seattle going to Redmond and Bellevue. There's this toll booth, and it will register every car passing by. There's a picture being taken by the car, it's being uploaded to blob storage, and then this blob created event created, which subsequently sets off a chain of functions because they subscribe to certain events. So one function will get this blob created, which has the URL. Okay, hey, this car. Okay, I have the license plate. I'm going to send this to Computer Vision API, which extracts the license plate using OCR. And then you see some other functions. They will save the license plate. They will look up the license plate in the database. Is it a known license plate? Is it connected to, let's say, a credit card? So this means that the person who was in the car could be straight away invoiced. If not, you get basically the fee for passing by the toll road or going over the toll road by mail. Okay? And I would like to demonstrate this part of, this type of solution. So I would just manually or at least through an application, send some license plates to blob storage, leads to the blob created event, triggers a function, at least the function is subscribing to those events, sends those license plate data, at least by downloading the blobs from blob storage to cognitive services. The license plate comes back and then it's being pushed back to the console application I've created. So I will kickstart my console application. It will upload those blobs to blob storage. It will lead to the fact that it will go to the cognitive services eventually, which I explained, and it will give those license plates back. As you can see, those license plates, just for figure of speech, these are Dutch license plates, as you can see. So those are being pushed to blob storage and then leading to the events. And events I can show you through, and I've done this a couple of times, and I'm doing this with the Event Grid viewer. So this is an application allowing you to also subscribe to the events. As you can see within the data property, it's put blob, this is the URL. So the function will also get this information and will take out the URL, download the license plate and send it to cognitive services. And this is within the storage account. So this is storage account v2, which has support for Event Grid. So this is what's called a system topic. So the events will come in, they will be subsequently routed to the service. So you can follow this. So this is where the subscription is of the function, PNG files, and this is the specific container. And you can also have the Event Grid viewer, which is just a web API in an app service, and it just subscribes to all the events. So this was my Azure Event Grid demo. I hope this makes a bit of sense about the technology and how it works behind the scenes a little bit. Okay, don't forget some other aspects about Event Grid. So the subscriptions, you can also enable dead lettering. By default, Event Grid will try to send a message to its subscribers. And if it fails, it will do this exponential backoff mechanism all the way up to 24 hours, and then it will drop. But if you configure in subscription dead lettering, which just means that you're going to push the events to a storage account, which you have to create, then you have dead lettering capability enabled. So don't forget that that's the way of enabling dead lettering. Use Event Grid Viewer potentially for troubleshooting, looking at how the events look. So I've done this also in the demo. Remember that the batch size limit for the Event Grid, it's kind of a JSON array being sent. So in total, the array can be 1 megabyte, but each event is limited to 64 kilobyte max. So remember that too. It's a serverless technology, so under the hood it's Service Fabric, so you don't have to worry about anything. This is completely serverless as it can get. Also remember that you can also leverage Event Grid domains to manage the events of flows of different systems. And then you can flow those to different business organization customers. So there's even some controls you can set on your Event Grid. And then there's a difference between a system topic. So a service in Azure that supports Event Grid has something like a system topic baked in. You can create your own custom topic, or you can create a partner topic when you want to hook up a partner receiving events from them. Let's say from ServiceNow you want to receive events, or from Zendesk you say, hey, you're going to talk to the partner, and then you can set up a partner topic. Those are some of the aspects around Event Grid as well, and you can find those aspects back in the documentation of Microsoft as well. Okay, so Microsoft Azure has this capability called Event Grid, which is available on their cloud platform. So they can support event-driven architecture, which I talked before, as this, with this event bus. But there's also competition. There's other cloud providers offering similar services. So Azure Event Grid was one of the first. It was G8 a couple of years ago, I think about 3 years ago. It was G8. And then subsequently, other cloud providers started offering similar services. So AWS has EventBridge. Again, there are sources like AWS services, custom applications, SaaS applications, and can send events to either at least AWS services can send it to a default event bus, or you can have custom applications sending to a custom event bus, or even some SaaS applications where AWS partners with can have their SaaS application as an event source, sending it to what's called a SaaS event bus, and then you get this filtering mechanism through rules similar to Event Grid, which can send it to multiple targets, which are depicted on the right hand side. So for this, I've kind of built up a demo as well. So I have a custom application in .NET, sending out events to a custom event bus configured in Amazon Event Grid, which has a rule which says, hey, if there's an event coming in, I will send a message to Amazon Simple Queue, where subsequently there can be, for instance, a function, a target, picking up that message. I will just stick all the way up to Amazon Simple Queue. So I will start my console application, which will just send the message to an event bus, which is depicted here through the AWS resource name. This is where the event is being sent to. This is the identifier coming back from that custom event bus. So how does this look in the cloud? So this is Amazon EventBridge inside the AWS console. So I set one up, event bus, which is called my event bus. It has a rule targeted to it. If messages come into this custom event bus, then send it to a my queue, which is a queue in simple queue service in Amazon. So it will get the message, and this is a previous one. Just let's do some polling again. And the time currently is 70:45, so that should be this one. And you can see the similar identifier coming back and then the details. So this is, just to give you an insight, this is how it works in Amazon. Pretty similar, right? Okay. Then Google also followed up, when Azure had its Event Grid and AWS had, EventBridge. So they came something with EventArc, which was released, pretty recently in GA, general availability. So again, you have some event sources, producers, sending it to an event bus called EventArc, which subsequently push those event syncs to its consumers. And first, it's Cloud Run service that is able to handle those events. So this is what Google offers. And then there's another service, and this is not really tied to one cloud provider. So the other three were kind of proprietary solutions. And it's called EventBridge, which was provided by Triggermesh. And as you can see, it supports multiple cloud vendors. AWS, Google, Azure, as you can see in this picture. Cloud events coming from Google pops up, Amazon EventBridge or Event Hub. On-premises, where it can have, as a source, and then can route those events to other on-premise like Kubernetes, Canada. So it's pretty, generic type of service, I would say, compared to the other cloud providers, because this kind of plugs in for, anything to everything kind of thing. Okay, so what are the key takeaways, with regards to building event-driven solution leveraging Event Grid? So it's a modern architecture, or at least you could say modern architecture, because now it's kind of the exchange of data based on events, and it's on proven principles, proven technology, because I showed you some use cases where you can leverage this technology, and it is a mature service for event-driven solutions. And the entry of it's a pretty low barrier of entry to go and use this technology, because it's serverless, it's available in the services in Azure that support it. You can send custom events, targets, I showed you it, and similar cloud providers like AWS have similar services where it's pretty sophisticated doing similar things. Okay, there's some resources you can explore, Azure Event Grid documentation, the Architecture Center where you can find some of the use cases, or some hands-on to find use cases, service notes, InfoQ, so you can find articles on this website. On Q, it's supported by QCall Media, which gives you some insights in some of the services I talked about. So Event Grid, but also EventBridge, EventArc, and EventBridge from AWS. Medium blog, so these slides are available. And then the other thing with regards to Event Grid, I've written an ebook available through Kofi, Service 360. So you can download this book, and this is kind of, gives you hands-on lab as well, but also you can look into some of the characteristics of service. So you can really, if you're going to start with this technology, I think this ebook will definitely give you some hands-on experience, or at least some insight how to leverage and use this service. Okay, so I would thank you for, viewing this session. Here are some contact details, my Twitter handle, my email. You can click on LinkedIn, InfoQ editor, or the MVP icons if you like, if you download the slides, so you can find some other stuff about me as well. So I would say thank you for your attention, and goodbye.